Next example, we're going to dilate something by a scale factor of 1/2. So if I take t, which is at, let me make this a little bit thicker. I don't like that being so thin. If I take t, which is at -4 and -5, I'm going to multiply it by 1/2, and that's going to give me t primed. So t primed is going to be at -2 and -5/2. I'll do the same thing when I do r. R is at 0 and 6. So if I multiply that by 1/2, r primed is going to be at 0 and 3. And then finally, we'll do the same thing for s. S is at 4, 3. So s primed is going to be half of 4, which is 2, and half of 3, which I'll say 3 over 2. You could say 1.5. You could have said -2.5 for t primed. It's fine to be a decimal. Now, on the next one, I'm going to go backwards. I've already done the dilation. I want you to find the scale factor. Well, you can do a couple different ways. Number one is we can do it just like we've been doing. Look at point A. Point A is at -1, 2, 3. So A is at -3 and 0. A primed is at -9 and 0. What do you multiply -3, 0 by to get -9, 0? Well, you multiply by 3. So my scale factor is 3. Now, I could have done it another way. I could have found the distance from B to C. I could have found the distance from B primed to C primed, and I could have divided them. Actually, I don't think I even have to look at the distance here. Look at how that one's such a nice diagonal. Look how that works out. B to C, I got 1 for the diagonal, don't I? I'm looking at the diagonals. And then B prime to C primed is 1, 2, 3. So 3 divided by 1 gives me 3. Yes, I could have found the distance formula. This would be the square root of 2, and this would have been the square root of 18, which simplifies to 3 square roots of 2, so notice it's 3 times as big. Yes, we're going to have to do some simplifying radicals on these. Let's do your 4 or 8-1 assignment.